Okay. We're live. Morning. Hey, how's it going? I think we're gonna do some algo side work just for the morning on this new thing I've been trying out. Morning, Nishant. New algo you're testing against generalized advantage estimation. So the goal is to kind of learn a form of discounting by expanding the value head to be like 32 dimensional or 64 dimensional or whatnot, and predict the reward for future time steps. I suspect something is still wrong though, because it's not learning the way I would expect. And finally lost. Yeah, but there's only one head. So it predicts future discounted return. And then you have to tune a discount factor. Whereas if you were to just predict all the future rewards directly, you shouldn't have to. Try something real quick. I just want to see if I can get it to learn something. Okay, so the mean tensor learned perfectly. And then standard deviation tensor. Okay, good. So this does actually do what we expect. It is learning a reasonable standard deviation and a reasonable mean. So then the only thing that could be screwy here is the data could be wrong somehow. These have to be the right ones, right? Because yeah, so reward block is already indexed, right? B. Hang on, I don't think that this is correct, is it? No, hold on. I might have something here. Let me see if this is actually correct. So, self.values. So anything that gets passed in is already sorted. Yeah, this is already sorted. But now this is going to be the wrong shape, isn't it? So, think the obvious thing here I hate when my extension just breaks for no reason. There we go. Experience no attribute horizon. Really? Ah, I forgot this one. One of these times this is going to do something. Eventually this is going to do something. Oh wait, yeah, it's doing it. Look at that. Mean is going to take a little longer, I think. But actually, no, mean should be that way. Standard deviation tensor, though, look at that. It's learned, it's going to learn its own discounting. Beautiful. Now, this, we're going to track this thing. And it will learn its own discounting. We'll see whether it learns it any quicker, but we do have the thing. Apparently there's a bug with some nans at some point. Yeah. It's weird that we have this. We're gonna have to figure this out separately. Okay, so something is definitely, we need to fix this first before we can do anything, I guess. Of course, the second you don't log it, it works. Somehow the standard deviation can become nan. Hmm. I don't understand how this can overflow. Bar Y. This literally should just be for logging. Weird that it only happens sometimes as well. Ew. Okay. How'd that happen? Something's very screwy. We have seen the signs of life, though. It is able to learn some sort of bit distribution. So there is a chance that if we fix this, we actually get something good out of this approach. Okay. Yeah, why does it do this? Can't possibly be this, right? I mean, that is technically an out of bounds, right? Non-deterministic errors are annoying. Maybe that was all. Just an overflow. Looks like it. Standard deviation clipping screwing this one, I think. What's the issue with GAE? That it has two hyperparameters that are environment specific. So you can't run the same thing on multiple different environments. And if you wanted to say train on multiple environments at the same time or something, you wouldn't be able to. So it's a fundamental problem with the algorithm. There we go. It could. I mean, GAE is a hard baseline to beat, right? But I do see that it is learning appropriate variance terms. So that's pretty cool. The mean term should actually be roughly even. So that's fine. And then the variances should be approximating a discounting factor. Which it looks like they are. It's not getting calculated at the moment. There were a couple terms that were broken. We'll fix those. I just want to see if we have the method doing anything reasonable. Yeah. So far, this is doing better than any of the previous trials where I had some stuff broken. But it's nowhere near the JE, the tuned JE run yet. Should at least do better than the previous runs, you would hope. Do we get stable value loss now? Oh yeah, we get stable value loss. So So that's fixed the previous issues. Not stable. It's weird that it's not stable. Well, it has done better, at least than the other ones. Okay, so 500. Next one will be 32 steps. Because I think there's still an issue with the way that we're computing things here, but this could do something. I'm gonna go. I'm gonna do a couple things while this runs, and I'll be back in a few, and we will continue on this for another hour and a half or whatever. Be right back. Okay. I had the Neptune on. Where's my run? Oh, look at that. It's hard to say which of these is going to be better because, like, it's a weird shaped graph, but that's a way higher amount than I've seen on any of the previous ones. And it looks like you're getting a pretty reasonably learned discounting as well. Oh, I think I did a sweep before as well, so this is definitely a reasonable baseline. Here we go. Oh, actually, yeah, this is substantially better. Thank you. I was looking at episode length. So, blue is 32 max horizon or 64 max horizon. This is 32 max horizon, and then this is the GAE baseline. Now, the thing is, it should get strictly better over a longer horizon. We just need to come up with a better advantage function, is my guess. Yeah, this is totally fine here. This loss is good. So it's got to be the other loss, which is the advantage calculation, which is right here. I'm just dividing by the standard deviation right now. Yeah, this thing's got to get normalized somehow. Yeah, that's just a bad advantage function. Okay. what did I make the advantage function? Reward minus mean over 1 plus standard deviation. Wrote out the RLC game. Wait, you already wrote an environment? There's no way, right? Check all the DMs. Oh, you wrote out the... Okay. I shouldn't put this on stream, right? Let me see. Okay, cool. So, I mean, I can look at this with you then. You got a capacitor. There are only two knobs here, right? Oh yeah, when you have two knobs like this, see, these aren't even actions, right? It's a one-step problem. You're just setting these and then running the whole simulator. Like, you could even, it's honestly easier to think of those as just like, you could like use a hyperparameter optimization algorithm for this, frankly. This is like so incredibly simple because it's a one-step problem, right? Yeah, so that's pretty easy. Like, yeah, you literally, like, the new hyperparameter algorithm that I have, you can, like, throw just the hyperparameter algorithm on without the RL, and that'll still work. Well, yeah, the thing that's missing here, right, is usually there's an interactive element in RL. But I mean, I have tools for this, sure, that's fine. Well, I mean, you hit, like, you make one decision, you hit simulate, and that's the whole thing, right? If you're playing Pong, you're moving the paddle at every single step. It's not like a step simulator. Hmm. Well, it's just like, it's not bad, it's just easy, right? It's an easy problem. Yeah, you have a two-dimensional optimization problem, one step. Well, yeah, this is just good enough for now. No, it's 40. But the thing is, it's not 40 just for Grok. They doubled the price, so presumably it was 20 for Twitter Premium before, right? And then they added 20 for Grok. So it's the same price as the others. This is still incredibly stupid. The suggestion it just gave me. What? Oh, that's screwy. All right, that's good enough. That's some data. We could try this. The standard deviations. What are you looking for? I'm just trying to find a nice way to scale the data. Huh. I guess that works. Oops. So this is now going to scale the advantages a little better. And this should actually make it robust to longer horizons as well. Essentially what this now does is the expected shape of the advantage curve, or the rather the standard deviation. Here, where's it go? So the expected shape of this curve, right? It's going to be something like drawing is hard. Flat line. And this is like 0.1, something like this. Okay, so this needs to contribute 0, and then this should contribute like 1. We just needed a normalization factor. Now we'll see if the one I came up with is any good. You know, there's no guarantee that the one I came up with is any good, even though it makes sense. Seems like it's underperforming for now. Maybe it catches up. We'll see. Just a little bit behind, I think. Oh, maybe it catches up. You can see it's learned the standard deviation. And then we also have one more normalization scheme to try after this as well. This should have like totally crushed the yeah. There's something I guess just with the learning rate of kneeling that it just can take off at some point. Man, that is so close to having it solved. That is so freaking close. 816. You can try normalizing. I don't think normalizing is going to do a ton for this, honestly, but we'll try it just to see. I'm out of thinking fuel for the time being. Let me just see. I mean, this is like so freaking basic, but. Like, can't I just initialize the parameter better? Log standard deviation. No, it's because it sets the log standard deviation to 1 to start with. Wait, but why should I? It's just going to tell me to add epsilon, isn't it? No, I don't want to do this. Why would I do this? That's not it. The hell? Oh. Can I just do this first? This. Whenever I'm doing like basic math, you'll watch like it takes me way longer than it should because I don't do it very often, frankly. But That's fine. We get through it, we make the algorithm, and then we make up for it in engineering. Okay. So we can't remove the min first. So silly. Stuck on something like this. Here's what we'll do. Isn't this just a way easier version of it? If we're deciding to not be stupid? Yeah, it looks like it. And now this one can be a sum, can it? That ought to be stable. Okay. Again, we have no idea if this even helps. But we'll run this, and then we'll run a longer horizon. And longer horizon should be strictly better. So the trick here, right, is that a property of this algorithm should be that increasing the horizon should cause it to do strictly better. It should not be getting confused by longer horizon, because the standard deviation will be flatlined at the point where it can no longer have any effective prediction that far into the future, and that gets subtracted out. So that has no effect on the advantage. A lot of problems are defined by less than 100K parameters. What do you mean by that? Problems. I don't know what you mean by defined. It would be, are they solvable with less than 100K parameters, right? Yeah, okay. So, how large of a model to solve? It depends. I think you'd be surprised what you can do with less than 10 million parameters. And, 100K is perfectly good for doing very, very fast research. We do a little larger than this. We go up to 1 million at times. Huh. Promising. How does model size scale with I/O? Well, that doesn't really tell you anything either, right? Because there is a scaling factor with that, but 999 of those inputs could be worthless, or they could just be linearly related, in which case you just need one layer to sort that relationship out, right? So it depends. It depends mostly on the fundamental complexity of the problem, not just the dimensionality, right? It's just how hard is the problem to solve. That's it. Like, the neural net is learning a function that's mapping inputs to actions. How complex is the function required to solve the problem? That's all it is. Convergence. Yeah, but it's not. There's not like a. You can't just fit big O to it, right? First of all, there's no n to scale it with. It's like if you have one simulation or another simulation, one problem or another, like there's no scaling complexity factor to a lot of these things. It's a constant. It's a big constant. You're trying to estimate the big constant. Yeah, of course each sim scales differently. Like, the thing to look at this is just like think about it at a high level, right? They're each different problems. Some problems are easy, some problems are hard. Some problems are easy for people to solve, some problems are hard for people to solve. Well, some problems are going to be easy for neural nets to solve, and some problems are going to be hard. There's not going to be a one-to-one mapping of which ones are hard for which either. But generally, right, I can look at something like Atari and say, yeah, that's going to be an easier problem to solve than Dota, and it's going to require a much smaller neural net. But there's nothing to quantify over, right? Like, you don't have any input variables that describe the problem. They're each completely different. This is not like an algorithm where you're scaling n and seeing how, how the complexity changes. Oh, yeah. Okay, if you have an existing problem, right? If you have an existing problem that has an existing known solve complexity or an algorithm with a known solve complexity, yes, you can use RL as a fast approximate algorithm in some cases. That makes sense. Yeah, that's valid. That is valid. This is so freaking close. I know, right? It's so close. Isn't that kind of cool though with Puffer though that like I am designing an algorithm to potentially replace one of the most widely used things in the field in the span of about 2 days of work. Exascale level. Exascale was big back in 2018. It's not huge nowadays. You can just go buy yourself a petaflop. Your company. What's it now? 20 million? They probably have overhead. 100 million? Just go buy it. There's no way that this is going to seriously do worse, right? If this is going to do worse, we're going to have to take a look at our formula. I mean, it should do better in the sense that it should at least be trying to estimate values that are farther out. It's getting more training data. We also haven't tried learned parameter yet either. Layer. We should try that next. There we go. Yeah. Yeah, not amazingly stable yet. It's untuned though. And let's remember, it is quite possible though that we just run tuning and just the optimal learning rate has changed and stuff. It's possible that we match just off of tuning. And mind you, the tuning will also be quicker, or fewer samples rather, because we no longer have to tune lambda and gamma. They no longer exist. It is irritating me that this doesn't seem to match quite well, though. And there it takes off, right? A little bit. Well, this is the whole algorithm, right? Is that you're predicting all the values. You don't need to learn a discount factor over values if you just predict all of them. Okay, so this definitely does worse. I don't know why this would do worse. That's the issue. I mean, these curves, though, are so chaotic, like, it's hard to say, right? Yeah, I'm not going to be confident saying one of these is way better or way worse than the other here. Curves are pretty chaotic. Do you have suggestions coming to RL? I have a full guide for you. I put all my suggestions for newcomers to RL in one quick, easy blog. There you go. We've trained several people actually in RL that came in with no AI background, let alone, deep learning, anything else. RL used to be incredibly, incredibly difficult to get into, like really freaking hard, but we've made it a lot easier. It's only going to get easier as well. We're working on simplifying a lot of the algorithms, cutting out a bunch of old crap. Okay, we're going to try this next, which is going to be learned standard deviation. Except am I dumb here? Wait. Yeah, you stupid. There, do this. This is so darn close. Input not linear. Must be tensor, not linear. Which conferences do you try to attend? Well, I went to NeurIPS this January and it nearly killed me, so I think we're going to be a little bit more selective. Yeah, NeurIPS. I mean, we're going to be more selective about going to conferences at all. Because I can tell you that was not worth what that was not worth it. Your conferences don't have peer review? That sounds great. Yeah, we have notoriously terrible peer review. Just awful. Well, I don't know what's happening with the standard deviation of this tensor here. Broken. What didn't you? Oh, I got pneumonia at NeurIPS and nearly died in the hospital 2 weeks later. That's what I didn't like about it. Conference was fine, but why is this doing this? Parameter. This is bad initialization. Something is weird here. How is it pushing this one to be crazy negative? And wait, how is it? It can't have a negative standard deviation. That doesn't make sense. Oh wait, because I didn't. Maybe I'm just being stupid. Hold on. Yeah. So it's gotta be torch.x. Yeah. Yeah, I think just checking out that link if you're interested in getting involved in RL, honestly, building stuff in PufferLib is the best way now. To give you an idea, all these environments are made by contributors, or most of them are. I made this one, and this one. The rest are other open source contributors. Many of them came in with no RL experience, let alone AI experience. Yeah, and they're all super fast, they're playable, you can watch the agents playing them. So it's a really good way to get involved, is just like building an RL and training on it from scratch. Okay, this is way more reasonable looking. Okay. There we go. How do you make the most of your graphics? What do you mean? I don't know what that means. Game dev? Game dev is fun. Game dev is that's just engineering X, right? Some of these are very, very simple. The only asset here is a puffer. And then we've got stuff like this, right? That's a little prettier. Maidenenv and PufferLib. PufferLib took a little bit to get used to Python integration. Sorry. I'm looking for a way around that, but the problem is there are really no good like binding options from Python to C. I'm trying to find better ones. Env is running over 1 million steps. That's what we like. Based on the ocean example, still need to figure out how to get it training. Yeah, so that's going to be the learning curve bit. The most common problems are incorrectly computed observations, like not populating a buffer correctly, or like not handling resets the way you think they are. Usually those are the most common ones. Oh, that's what you meant, RayLib, yeah. I don't know why this thing doesn't seem to be training at all now with the learned standard deviation tensor. Because the standard deviation tensor looks good to me. And we'll let it see, maybe it just takes longer to take off. Regardless though, we're very, very close here. What do you guys think? Does it make sense for the standard deviation of the output to be learned per instance, or should it just be a parameter? So like basically, should it learn a per time step variance, or should it learn a per observation per time step variance? For instance. How are those two different? Well, you can either define it as a neural net dot parameter. So if there are 32 time steps, you're just going to learn 32 variables, and then for every observation, you're going to get the same standard deviation on them. Or you can have the variance actually be predicted by an extra head on the network, and then you can actually have the network learn to predict when it's confident and when it's not on each time step. It doesn't seem to train though, which is odd. Because I'm looking at the standard deviation tensor and it's pretty reasonable looking to me. Like that's a very reasonable looking standard deviation tensor. So I don't know why it wouldn't be learning. Oh, it is learning. It just took forever to take, like, to start. Huh. That's weird. What do they use for the value net? Predict. Standard deviation 1 for the value. It collapsed again. Very awkward. O1 on the action head, then 1 on the value. Doesn't learn at all. All right, make sure I didn't break anything else. Otherwise, it's the same, right? This one, whoops. Go. It's crazy. It learns much better. And that standard deviation is really important as well. It's being a lot more conservative here, where it's like not trying to use predictions too far out. That's interesting. What the heck are these things? Fine. I don't know why this wouldn't train. The other one wouldn't train at all. It's very weird. What? That's not how that works. Yeah, this thing fundamentally does not understand. I don't know. Yeah, that doesn't make any freaking sense. Good job. It shouldn't be anything fundamental, I don't think. The per instance would be really nice. Hi, welcome. I mean, at some point you've got to assume there's just a bit of variance in the curves, right? I mean, breakout is known to have a ton of variance. Obviously, there's still a gap to JE, but these little tiny tweaks, I don't know if we're really measuring differences between them very much. I do want to try, I think 128 horizon. That would be a good data point to have just to see. The idea is that with the current implementation, you should be able to expand the horizon and you should not suffer performance penalty. It should be able to help if you're able to learn it, But if you're not, it should not hurt, because the variance should essentially be 0. $720. Yeah, okay, that's not far off. That's fine. Those are all fine. Can I fix this? I forget one of them? Yeah, I did. We'll make that a learnable parameter as well, maybe. Or sweep parameter. And I'm just going to do this so we can see it. It does look like it slows the algorithm down, which is not great. I don't think it should. Final year undergrad, I want to create. Final year project in RL. Very confused. Still, I heard RL is still far away from being used in real life. No, it is used in real life. The thing is, it's not used out of the box in real life. It's kind of at a point where if you have an application, you got to go hire some smart RL people, and give them a couple years to make sure they really get it working. But so it's not out of the box, but it is used. Now, if you're trying to do like, a cool project, that scale of a thing, yeah, we have a lot of these things. So Puffer AI here, right? We have all these different environments that are built for really fast training in RL. You can watch the agents playing them live. They go from very, very simple like this up to very, very complex, like this miniature MMO. And you can kind of watch the agents run around here and do different things. Sometimes they get stuck, but they actually will, if you watch them, they'll do some pretty impressive stuff. Same with this MOBA. We have it working in a variety of different areas. Won't get any job from RL. Well, it's not really it's not really an undergrad job is the thing, right? Like where RL is right now, you're mostly hiring RL PhDs. That's the tricky thing. But general ML, there's tons, right? Like it's all the same stuff. There's tons and tons of stuff in general machine learning. It's pretty easy to just float around from one subfield to the next. I mean, I don't know your background level, right? But if we have some of the simplest RL code out there. So you can look at some of the example environments and the way we do stuff. And if you say, oh yeah, that looks like something I can deal with, then you're set. I like this one. This is massively multi-agent snake. We can definitely get things working. It's just takes a little work. All right, so here's the latest one. And yeah, so there is definitely something going on with the longer horizon. Longer horizon should not hurt learnability, but it looks like it is. I'm trying to think why that would be. It must just be the noise, right? I mean, unless this thing is going to take off massively. Maybe it's just that you're getting a little bit of noise. And we'll have to actually go look at how much of the training, how much of the data is noise. I could clip it, maybe. Kindly suggest a cool project. I've done specialization in RL from course. I didn't even know they had one of those. I mean, generally what you do is you pick a simple game, right? You pick like a simple game that we don't already have. You implement it. Take a look at the way that we do stuff, because we do stuff in a specific way to make sure it's very fast. It's very simple the way we do it. And then get RL training on a new env. So pretty much like showing you can do the whole end-to-end process of here's a new environment, I implement the environment, I get the RL training on it, here's the agent that is trained on it. That's kind of what we suggest to people who are relatively new in RL. I mean, a lot of these are not a tremendous amount of code. I think that this whole thing is less than 500 lines. I mean, the core logic is really 132. Yeah, like 200 lines. Doesn't take a lot to do some pretty cool stuff in RL. PufferLib tries to make it pretty easy. Idea in finance. The one that people always want to do is they always want to do like market sims. I wouldn't try to simulate the actual stock market, but I will tell you that like you can definitely do some sorts of like trading type simulators. I can show you like a very small thing that I've done in that area. Well, it's not a small thing. It's small because it's embedded in a much larger thing. But here, like these agents, if I just take over for this guy real quick, I can like buy and sell stuff on the market. Just like with key presses. So this agent can buy and sell stuff with like 100 to 1,000 other agents in the same environment. So you can implement some sorts of like basic trading simulators like that, and then track prices, track supply and demand, that type of a thing. I think Salesforce had a thing on this that was kind of ridiculous. OSS RL. I mean, they were doing it for tax policy, which was kind of stupid. But where is it? Where the hell did all the images for this thing go? Yeah, so they were doing stuff like this, where they had this simulation and the agents like could trade and stuff. I wouldn't try to embed them inside of an environment. I would just do the trading portion. Like agents have certain amounts of goods, Agents, produce different quantities of different goods. Agents all need a certain quantity of different goods, and then see if they can learn to trade with each other efficiently. That type of thing is pretty straightforward. Okay, so this definitely hurt performance. And the question is why? It's gotta be noise. It can't really be anything but noise, right? Ah, and actually it's not slowing stuff down either. It's just the wrapper is apparently slow. So that's fine. We'll fix that. That's no problem. I wonder if we can just see. I wonder if we can just see it here. Gonna have to hit continue a whole bunch of times. Until the standard deviations get to a reasonable distribution. I'm trying to think in the meantime what else it could be. I would think it would have to just be. It would have to be the advantages. I mean, there's just nothing else, right? Okay. Ah, shoot. It's gonna eat all those continues, isn't it? I didn't think you could buffer those. There we are. Okay. So, zero. We're capturing 90% about the first half. Which is not enough, because clearly there's nothing else after that. Yeah, that's just noise. So, you can't clip it is the problem, can you? Oh no, you could clip it. But the thing is, how would you clip it? To 0.02 or something? Hmm. Alright, we'll see how that goes. Be right back. Well, this is weird, isn't it? Is this still not doing well? I clipped it. Should also figure out the miscellaneous time, what's going on there. I mean, the standard deviation tensor here, right? Like, it's only maybe the first 16, somewhere between 16 and 32 elements that actually are significant. We'll let this run finish. But this doesn't seem to be doing what we want. We could just test this at 32 length, but I think that we're leaving performance on the table here. Thing is, I can't think of why that wouldn't work. Clipping this should prevent anything screwy from happening in the advantage. I guess it could just also be the loss is really noisy. The value function loss is really noisy. But I don't think that makes sense. If I look at the value loss, right? So this is our value loss here. And yeah, it's going to be higher, but it's not noisy. It's actually very stable. I could also just zero the second where everything after 32 is a comparison. Because that should definitely work, right? And if that doesn't work, then there's definitely something broken. I'd also just like to know why the MISC script takes so long. We'll double check that to speed up our training runs. But this is going to be about the same, if not a little worse. Okay. Be done in a second. Is there not an HTML? I want to see the HTML. Unknown. Look at the top. Isn't there an annotate flag? Hold on. Yes, this is it here. Interestingly, this is fine. Should not take that long, right? Maybe this just gets ported to C or something. I don't know. This is weird. Regardless, though, right? We should be able to do this. And if this doesn't fix it, then there's something else I'm missing. Because this should make it the same as the 32 one. heck is this? Damn it. What are you doing in my dev chats? I think this is still underperforming, isn't it? You see? I mean, we're not going to be able to tell for a while. If this matches, at least then we'll know that the issue is in the way that we're handling clipping or whatever else. I don't think what function would be suitable for that. And also why clipping doesn't seem to do enough. Still doesn't match, right? Crash back down. Oh no, maybe it is. Okay. We'll let it, we'll see. If this matches, then it tells us directly that the issue is just the variance post-processing. Looks like that's the case. Take this as an opportunity to commit the current stuff. Is there a reason to expect this to do better than previous? I think not really. I think it should just about match. I wonder what actually causes that in RL. I mean, that actually seems like there's policy damage, right? That's not just random variation in getting a bunch of bad samples, I would expect. That actually would be another good topic for research. Why the hell our curves are such a mess? No, that gives you these little squiggles down here, right? These are just sample by sample squiggles. But when you get stuff like this is actual policy damage, right? Like these are not random action sampling. This is like it's like something screwy happened. Hey, welcome. The fact that it's not matching what we had before concerns me. Oh, okay, maybe it is just end behavior. With one unlucky spike, yeah. Okay, fine. At the very least, there is a substantial gap just caused by the way that we're handling variance. We know that. I think we can probably handle these things separately though, right? Because if all I do is, here, I think, so I want to go get lunch and do some exercise. So I think what we're going to do, we're going to set this to be 32 and 32. This should be the stable one. And now we no longer care about gamma and lambda, right? Take these out entirely. Now we're just tuning this stuff. Really the one that matters the most is going to be like learning rate, batch size. Okay. Total time steps do we have in here? Yeah, this is fine. Yeah, this is fine. We'll just leave this on as is. Let's make sure that this actually trains. Just get rid of this. It's like leave this scale like this maybe. And this will be committed as well. I think what I'm going to do from now on is when I have like cool new research like this, I might not share it on Twitter, like in post form. So, you know, there will still be a decent little surprise for the general audience. But yeah, if you're on the stream, you just get to see whatever the heck I'm currently doing. Because I think this will be a really cool result. If we can get this to match, this would be huge. There's still some quirks. Definitely still some quirks. And let's go take a look at this one here. Oh yeah, that's way closer to the original curve. Now it's got this dip. But yeah, there's definitely something screwy with the longer horizons. We'll figure that out though. There's no big deal there. We'll figure that out for sure. And then it'll just do even better. I think I want to set this up already. Do you get a bunch of emails? Yeah, they just go to spam though, right? I mean, even then, it's just not a good use of time. Okay, cool. So, quick summary of what we have right now. We have a stable implementation of this generalized advantage estimation free PPO that, with completely untuned hyperparameters, gets pretty close to the original with JE, and, well, not completely untuned. It was the old ones that were tuned for JE. So then the question is going to be whether we can match this via hyperparam sweep alone, or if we need to keep working on the algorithm quite a bit. I'd honestly be surprised if peer review is even directionally correct in AI. Is this? I don't think I could have broken anything here. Okay. I think we're just going to leave this to run because we're probably just spending time analyzing random noise here. Yeah, if we're able to do this, then basically we'll have removed two hyperparameters, which you always have to sweep, which are really annoying. It will have the potential to do better because it will be able to have a flexible horizon that changes over the course of learning, which should be important in more complex tasks. And it will allow the algorithm to work more robustly across multiple environments. So I'd say pretty good. And yeah, this is close to on par as well now with before. You can see, yeah, look at that. Perfect. Cool. So I'm gonna go get some food. What do you decide to do? I just ran it with shorter horizon for now, for the sweep. What current ocean M's can we use to test learning over an adaptive horizon? Any of the more complex ones. Your one, potentially Spencer's one, Neural MMO, MOBA, any of the more complex ones. In fact, I know how to, Captain, I have a perfectly good way to track that as well. It will be very easy. We'll add a metric for logging it. Like, literally all I have to do is get this thing to be about on par with JE, and then we can do lots of cool stuff. Well, when I say all I have to do it, that would be like that would be like a giant RL contribution. So we'll see how hard it is. But it's going pretty well. I think we need to run the sweep to see how much we're missing out on. That will be nicely set up for us. I think this is our sweep, right? So this will be our sweep. And we'll see how this goes. You could initialize new tensors. Yeah, there's a lot of stuff we can fiddle with. Same policy for all. Not exactly same policy. It's just that these are two of the hyperparameters that are the most fiddling, right? And they vary the most across environments. So if we remove this, then it means that we'll have PPO will work way more out of the box than it currently does. I think we'll have to change the name from PPO to P3O, Puffer Proximal Policy Optimization. But I'm gonna go, while this sweep runs, I'm gonna go get some exercise, I'm gonna go get some food, and then I'll come back in the afternoon, we'll look at this. We'll probably have to work on a few other things as well because, I have contracts that demand work as well. But this is pretty solid. So thanks, folks, and If you're interested in any of this stuff that I work on here, it's all open source, puffer.ai. Start the GitHub, really helps us when people start the GitHub. 2 more people join the Discord to hit 1,000. That'll be pretty nice. And you can also follow on X, where I post a lot of RL content. Got a blog as well. So yeah,